record on my computer. All right. So what we did, let's see if I get this thing here. Lighting up here. I know I'm using a different mouse today. I may have to go for my original mouse if this one doesn't work well. Um, all right. I will not bother with that. If it works, fine. I don't have to do anything. All right. Um, so we look at this figure here. So you're looking like a trapezium, but you can see out of it, you can get a rectangle, you can get a triangle, and you can get a semicircle. However, the semicircle is hollow, so it's a minus area. So our first attempt is to, one, calculate the area of the figure. Two is to find the centroid. So initially what we do, we're going to locate x bar, y bar. What you do when you separate the figure, so let's say that you separated it here, right? A line coming right down. So you have the rectangle. Now you see that this is 120. So the x bar for the rectangle would have been 60, because 60 would drop it somewhere in the center here. If you map it down to here, you see half of 120 is going to be 60. So that will take you back to the origin from the center. All right, so that will be 120, 60. Now the distance coming down is must be half of 150, which is 75. So x bar is for the rectangle. So x bar will be 60, and y bar would be 75, and that's millimeter. For the triangle, we say that we must take 1/3 the base and 1/3 the height. So 1/3 the base, so it's 90. How much is this now? So we are saying if this is 120, and this total distance here is going to be, so it is what, 220? 120 from 220, how much is that? So that's 100, right? All right. So you have 100 so we are saying that the length of the base here is 100. We're saying the height, of course, is 150. So 1/3 of the base, so it's 1/3 of 100. So that gives us, is that correct? Is that correct? Let's double check that. So that was 90 plus that, yes, 220 minus 120. So it's 33.3. So right at the back section is 33.3. Up at the top, 1/3 of 150 is going to be 50, right? So when we have 50 coming from up here, so that would give you your 1/3 section. So that is 50. So let's work with that now. So if that is 50, right? If that is 50, we know so it is from O, for this one, our y bar is 50. And what is now? So the 1/3 for the 50 would be somewhere up here. So that would be 50. For the, if this is 33 and a third, so 33 and a third add to 120 to get the distance of x. So the distance, so x bar would be 33 a third plus the 120. So that would give us, so that's 133 and a third plus 120. So you get 153. So you get 153.3. All right. All right. What else are we getting here? The circle. The circle is, look on it. The circle is 60. All right. So the circle center is 60. It tells that this is 9. So this is going to be 90, because from the center out to the 0 point is 90. right? So out of the 0 point, is going to be 90. And up here for the circle, you would have used a formula to get that little distance above there. What is it? That distance there is going to be what now? 4r upon 3 pi for that little distance there, that section there. All right, I'm hoping everybody hear me. Whatever you add that section to this section that you have below, so it's going to be 30 plus that section. So let's look at it. Let's go around and look at the next slide. So, right, so you get the one third of that. This was 60. This is for rectangle, that was 75. This one we say was 90 plus this formula here that I was discussing last is really 4r upon 3 pi. Right? So it's 3 pi times it, you get that value there. All right, so what we do typically do is to take the area and you multiply each one of them. So let's gonna do it separately. I'm gonna just repeat quickly. So it's going to be 18,000, sorry, times 60. So let's check back these values here. So you're supposed to get a million. So we can actually edit this. So it's 1.08 times 10 to the, in your calculator, you could just put E. So it's 10 to the 6 for that one. What about this one? Let's confirm the next one. So it is 75 times 18,000. So you must get 1 point, put the point here. There's 1.35 times 6. Let's put the 6 here. The next line, same thing for the triangle. The area of the triangle, 7,005 times this distance here. Let's confirm that. 153 right, 0.3 times 7,005. So you must get 1.4, I think I round off here. Let's take off a round off. 1.1149 times 10 to the 6. Let's put the 6 up there. What is going on here now? I think I have an error there. And how do I get back that? It's 10 to the 6. I think I have an error. Equation. So let's fix that quickly. So I'm gonna put it's 10 to the 6. It's 10 to the 6 there. Right? And this one now, same rule apply. So it's going to be 7,005 times 50 for the triangle. So it's y bar now. 775 times 50. So you must get 375,000. So you could write 3.1, but this is 5. If you want to do that, you could put the 5 up there. All right, because it doesn't reach a million. All right. But am I not recording? Okay. All right. Next one. All right. So you're gonna add these columns. Note that these down here, we didn't check these. These are supposed to be minus. Let me just check them quickly. 5654.87. Right? Times 90, first one. Minus, so it's minus component there. The 50 is minus. So you should get yeah, the figure there seems to be correct. Right? We could put a comma here. That's minus though. All right, no little minus in front there. The last one, let's check that one. So it's 55.46 times 5 minus 5, 6, 6, 5, 6, 5, 4.87. So that gives you 13619. Right. It's correct. 0.0 or point 1. You probably put 0.1 or 0.01. Hold on. Point 1. Right? Okay. All right. Now let's add these over. I was just doing it before. So this is 1.06. We're gonna add the X bar column times 10 to the 6 added to 1.149 10 to the 6. All right. And then the other one would be minus 508,938.3. So we're getting 172 0 0 0 0 6.7. Yeah, so that looks correct now. 20. This one over here, let's check this one, this last column. So it's 1.35 10 to the 6 plus 3.5 10 to the 5. All right, you get 1.725 minus 313,619.1. So that gives you, this figure is not correct, 1,411,380. Actually, so you could put that as a million. 1.14. So we're gonna put a point here. How many zero we get in here now? So we could actually, that look like that makes a million, eh? So that look like that makes a million. So let's put an equation there in. So it is going to be, all right, so it is time 10 to the 5, 10 to the 6, sorry. So that's 6. All right, so it's below, but I like to have it in the column because I think the column makes better sense for understanding. All right. All right, so it makes better sense. All right. Let's see if I can. I'm trying to get this one here go out a little bit more. All right. Oh, it's different column, wrong column I'm moving. All right, so this one here not moving. All right. So it's 1.1 times the x here. All right. All right, so that's the value. We had minus it. So that now, each one of them now, so x bar up on the sum of the area, first one. So you're going to divide it. All right, let's do the last one before, since I have that in my calculator. And then you divide it by this value here. 19,845.13 should give the answer below. Hold on. Come on again. Looks like we have a column here. Something is had wrong here. I'm just checking what the addition here is going on here. So what they did was supposed to be adding these here and minusing this. What is, oh, okay. What is happening down here? There, let's see what, because I'm checking the working, just checking to see how correct this working is. So let me check about that again. So it's 1.141. If it doesn't work out, I'll leave it and fix it and send it back to you. Divided by the area, which is divided by 19845. Last attempt. Let's see if it works out. I'm getting 57. So all right, I will have to check this work in here. I'll have to check this work in here to see if this work in here is correct. It should be correct. I'm getting these values here. But anyway, I'm not gonna labor no more time on it. But it should give you each column here work out. So when I work it out, I'm getting 57.4. That's what I'm getting for that one. Let me see what I get for the first one. So it would have been 172. Right, let me go at 172.0061. Right, I'd have inherited these slides, but I'm expecting them to be correct. 45. So you get 86. So this first one is correct. This first one is correct. That figure is correct. I don't know why. So this one is all right. I got 86.67 for this. But the second one need checking. I don't know if I had something wrong. Could be me. Let me just double check that one. So it will be 3.75. 10 to the 5. All right. And then it's supposed to be minus 3.3619. So that is giving me 1.1 times 10 to the 6. That's what I'm getting. Look a little bit big. Divided by 19845.13. All right. Yeah, it's correct. So I got the two values. They are correct. So that figure here. So this figure divided by this over here. Right. So all I would have done if I was the one who created the slide, I would have done this. Let me just write it and show you what I would have written. Let me go full screen. So what I would have done, I would for the first one, I would just say sum of x bar is going to be equal to the sum of x a upon the sum of the area, which would be really 1 7. Let's close up this so I can see. 1 7. What is that? 2 0 0 6 1. So you don't have to do all of them long thing on the bottom there. 0.7 divided by 19845.3. And that would give you the 86.71. And you do the same thing for y bar. Y bar is going to be simply just the sum of y bar a upon the sum of the area. And this would just give you, what's that value? 1.411 times 10 to the 6. All divided upon the area there, where is 19845. Right? Have I missed anything? Right? That's 845.13. And that will give you the 71.12. All right, so let's run away from that. That's how you would approach that one. And that is fine in the centroid. So let's move along. All right, spend a little time on that. So that would show you that when you get the distance, you can map. So this is now, so this is your height above here is going to be, so this is x, this is y bar, sorry. This is y bar, right, where your centroid is. Your centroid C is right here. And then this is x bar. So x bar is this distance, meaning that the distance, I'm just trying to see the logic. So this is the point. So it means that the distance, wherever that distance is, that is x, and the distance and y will be that distance right there. All right. So this is x, that is y. All right. But you have to remember to minus the other section. All right. I have another one. Let me see if I have time for this one. Let me jump away from this one. This one will take up some time. Let me go with this one. All right, what about if you get a simple figure like this? So you have to start somewhere now. So you get a simple figure like this. What you do here, all right, so first you look at this now. You say to yourself, all right, how many figures are these here? Regular figures can you get out of this? You notice that you have a segment that looks like a rectangle here. All right, good. And then you have another section where is a quarter circle over here. So I am saying from you can get a rectangle, hollow, of course, meaning that the area is a minus area. You can also get a semicircle, right? And after a semicircle, which is a minus area again, you can get a full, rectangle. And the full rectangle, what will be the dimension of the full rectangle? So this is 3. So that means that this distance here is going to be what? 10, right along here, full rectangle. And the full height is going to be what? 6. Why do you see that? Because this distance is 3 also. So 3 plus 3 is 6, right? For the rectangle, the triangle, sorry, this is 3 and this is 3, right? So 1/3 is going to be what? 1/3 of 3 is 1. So the 1/3 distance is right there, and the 1/3 distance for this one. So both distances are 1. That's 1, and this is 1. So, right? So that's important right here. So that meet up at 1. So for this one, your x is 1 and your y is 1 also. Let's check that. Is the y 1? No, the y is not. The y is not 1. The y would be, but the 1 from would be 5. So the y is 5. Everybody say that the y is 5. Y bar is your y component there is 5 for this. Everybody see that? And this is 1. I don't like teach a class and person not talking to me now. All right? Is that there? What? And
Sir said we're seeing you.
yeah, but I need to hear that you're hearing me and you understand what I'm saying. If not, it makes no sense. I maybe just need to just stop the class because I'm not hearing anyone. If you're not participating, you're not part of the class. You're an observer, right? And there's a big difference with that. And I'm quite annoyed with this group now. You're not talking to me. So it means that we may have to figure out and scrap this online thing. I'm kind of late in the semester now. Anyway, all right. So that is what is what. All right. So now, okay. So those are so it's 3 figures, and these are regular figures. So you need to go ahead now. One, find the area of them, right? So we know all of the area. We know the area of this one is going to be half base times the perpendicular height. So that is easy. So that is just half times 3 times 3, right? So that's 4.5 millimeters square. And for this one, it's quarter area of a circle. So it's pi r squared divided by 4. So it's pi times the radius, which is 3 square upon 4. And this one, of course, is easiest one. Is length times width or length times height, whatever you want to look at it from a pictorial sense. All right? So that one is 60. All right? So now we need to identify your y1 and y2. Calling y1 and y2, I won't call it x bar because they can confuse you. So for this, for the semicircle, you have to use the formula again. The quarter circle. But this one was easy. What is the one for the triangle? Can somebody, not the triangle, the rectangle? Can somebody tell me the one for the rectangle? What would be this distance? Its center. What would be its y1? What is the x1? Sorry, and would be y1. What's that? Those are easy ones. So this is y.
5 and 3.
No, it couldn't be 5. It couldn't be 5.
Wait.
One is 3. What is the other one? What did they say it was what? Come again?
3.
5 and 3. Oh, right.
Yeah, 5 and 3. Yeah, 5.
X is 5 and y is 3. The other way around. Right. Okay, depends. All right, what about the circle? What about the circle? Or I should say the semicircle. Would you apply the rule? What would you? So let's look on the circle, the semicircle. So right, so the semicircle, remember, it's the same formula, 4r upon 3 pi. It applies to both circles, whether a semicircle or a quarter circle, right? So this one, all you have to do, you would just say, okay, so for the top up here, which means here and here, that distance, so you need to find that distance here where it brings to the center. So that distance would be, it's going to be 4r upon 3 pi. So you work out that would be 4 times the radius. The radius was what? 3, and this is 3 pi. How much is that value? Can somebody tell me that value, please? Can somebody tell me that value, please? Thank you.
1.27.
Let me check if you're correct. So that would be, put a bracket, and then I'm gonna put in 3 and how much you get? Check that.
1.27.
1.27. And you can get another one, 3. Right. So it means that this distance is 1.273. If that distance is 1.273, it maps right down to here. Right. So so that is from 10. So you take away that distance from 10. Right. So that means that your y, your x. Any which way you take it is this one for the x is going to be 10 minus that distance. And what's your y? Your y would be what now? It would be 6 minus 1.273. So you to get that distance there. Because it is both ways you have that distance. But it's what I'm saying. So for both ways you have it. So this is the center on that. And you'd have to find the coordinates coming from every direction. So this distance would be the difference between, so that minus 10 would be 8.72, 8.72, 7 or 6. That would be the x, that's the x distance. We could call that x3, so as to label it. And y3 would be now CM the 6 minus 1.27 3, and so that distance would now be 4.727. All right, so let's look in the table. You're doing it by the table. Let's go and look at how they did it in the table. So they typically just show you that you work out. So this is the distance here. So you need to subtract it from you could subtract it from the radius and then add it to the other distance, but you can't just do it otherwise, like what I tell you. Anyhow, right? Because the overall distance, you're mapping it to the origin. Each one of them, remember, each one of them must be mapped to the origin. So this point here must be related back to that origin over here. Right here we have O. Remember, so each one of them you have to map it down and you have to map it across for each one of them. Same one, you have to map this down and you have to map this across here. Right, those distances. So that would be your x and this would be your y distance. Let's go and look in the table how they did it. So for the large circle, which are there 5, so you have x and you have 3, which we have worked out already. So you know your x1 and so your area is that. For this one, it was what? Minus. Yeah, that is minus because it's other. And for this one, it was for this, it's pi r squared divided by 4, so you get that. Your y bar for these two, so for the triangle, we said it was 1 and 5, right? 1 and 5, remember? This one was 5 and 3, and this one was 8.73, and this was 4.73. Remember, those are what we got around here. I didn't write them down. I thought I wrote them down. Yeah, I told you them, but I didn't write them down. All right. So, yeah. All right. So what we do is typically here now, you're going to multiply the area by each one of them. And that's exactly what they have done here. So this figure here is 5 times, the first one is 5 times 60. See it here. Then the next one is going to be 1 times, right here you go. So 5 times 60, right, for the x1. And then the next one they have here is 1 times the area here. So for they're doing the x column first, and then the next one they multiply this now times this. Right? So see you have it there. So all of that would be the total x1, y1. So you could typically say that this is like
Wait, hold on, sir.
this is x1 times area 1, and this is x2 times area 2, right? And this is x3 times area 3, something like that,
All
right?
right, sir. Hold on. With the triangle,
Mm-hmm.
the 1/3, it 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 matters because the like where the triangle pointing, right? Like from the X.
All right, let's
So
look
that's
up
how
at
they you get the 1/3. And the next one because it
no, the
upside
1
down.
over 3
Yeah,
is the 1/3 rule.
yeah.
The 1
Because
over
like
3 is the 1/3 rule. Remember, look. It doesn't matter the shape of the triangle. I thought I had, wait, I thought I had them over here. Yeah, so the 1/3 rule, look, the 1/3 rule coming from the distance at the here. Says this one here. Says 1/3 is this is total length, which is 3. So that distance is 1. Right? 1/3 rule applies. Any side you take it, 1/3 applies. So both x and y is 1 there. So you're going to have to, so for the first one, to take it back to 0, for the x is still 1. But for y, it's going to be 1 from the total distance going down. And the total distance going down was 6, not true? So 1
yes, sir.
from 6, I must give you this distance here, 5. Give you that distance right there, which is 5. You got that?
Yes, sir.
Good. And this is 1. So x is x1 is, so that is x1 for that figure, and this is y1 for that figure. And then you do the same thing for the others. So we had worked them out as that was it. And for x1, if you call it x2 and x whatever, is the distance, you got 8 point something, and then this will give you how much is that? 4.7 something. So those would have been the distance. And then you have these over here, which I already told you was your x3 and your y3 would be one is 5 and one is 3. So let's get back to it quickly. So you you jump ahead and you will get those values here. But remember, you have to remember the ones that are minus, If you don't put them in, you get the whole thing wrong because you'll be using the incorrect one, the incorrect area, so that the minus areas them have to be subtracted. Because remember, it's all over here, so you could never put them in a solid. Right? If you put them in a solid, it'll be wrong. The only thing that I want solid is a brown area. So you have to subtract it, but that's why you have to do the whole rectangle, entire rectangle area, that area, you have to use them. All right, so we run ahead and you do the next one, right? I'm sorry that the table was designed this way. I'll have to redo it in my time. When I get the chance, I have to redo this table. So all you do here now, because I like to have them where you just do everything in the table. It makes more sense than do it this way. But anyway, so you go 3 times 6, let's go for the y now. So the first one is 3. 3 times the area and that was the circle. That was the rectangle, right? For the large rectangle. So it's 3 times so this would be now essentially y1 times area 1. Right? This one now is going to be y2 times area 2. This one now is going to be y3 times area 3. Right? And this is the total area. All of that is always this value down here and that value is the same. Because that's the sum of the total area, the shaded area. So those are constant. So that's why you can do it in the table. Because you would have sum of A. Sum of A is on the table. All of this equals the sum of A. They are same figures. So you just call them Y1. So you find Y1 and X1 and Y1 same time. You find X2 and Y2 same time. You find X3 and Y3 same time. And you keep multiplying them by the respective area. And you just simply add them. So this is the rule. The very first expression that I showed you have the formula here. I think it have the formula. If you remember when we started, see, we have that formula, and I think it should have a formula around here. If you run back around here, if it's not there, this is typically what's it. See there? This is it. It is probably not written in that form, in the same form, but it is really there. So it's really saying for X bar is going to be really X1, sorry, A1 plus X2, A2 plus X3, A3 plus X4, A4, and the sum of the area, which is going to be area 1 plus area 2 plus area 3 plus area 4, on. And the same thing for Y. So it will be Y bar will be equals to Y1, area 1 plus Y2, area 2 plus Y3, area 3 plus Y4, area 4, all up on area 1 plus area 2 plus area 3, right, plus area 4. That is the essence of what you're doing right here. Right? That is the essence. So there's no make no ambiguity about it's not difficult. It's one of the basic things in finding centroid, but one, you have to understand the figure on which you're dealing with. If you don't understand the figure, that is the first thing you have to understand. And it works for mass, it works for length, it works for area, it works for volume. Next week, I'm hoping to do a mass area, right? But now we are dealing with just regular areas. All right. So those are what you have gone through, right? So these are the known as composite figures. So you separate the figures and you multiply them across. There are many more. This is another one here. Let me just quickly look at another one quickly. Um, Let me see what time we have. How much time have we gone? All right, so we're almost gone an hour. Let's jump to another one. All right. I was hoping that I have another one good. Um, Hoping that I had another one. All right. Before I start inertia, I'm gonna go to inertia. All right. Let me run through inertia. All right. This one you're gonna have to do it yourself. I'll try and see if I could give you a. Well, you basically understand it now, right? This one you go through, you do the same thing. I just walk you through this one without actually doing it. So what you do here when you come here, and this one you have to know something here. Let me just explain to you this one here. Where is it? This one right here. So right here, you want to determine the centroid. You look, you see you have a hollow section, so you could divide up this into a number of things. So you see that you're gonna have a rectangle, which is mapped here. See here? Sorry, wrong way. See here? Right through the center of the circle. See here? So that's the first one, a rectangle. You have a circle, negative here. Right? You have a semicircle also. You see that? So you have a semicircle, right? So you can say that semicircle is a solid. That one is minus, this is solid, right? So this is the only one that is, then now you have a triangle down here. So you see how much piece you can separate it into? So you have a triangle and these are solid. The only difference is that this distance down here is minus, is the negative y. That is positive y. That's the only difference there. And then now what you do, so you have to consider that positive y and negative y. So the rectangle, you find the area of the rectangle already, see it here? That's a rectangle. And the rectangle is 120 by 80. So halfway it is, look, so halfway it is, this section is 60. So that what x1 is 60, and this y1 is, this y1 is 40. Done. You get it. See them there? 60, 40. The next one, they do the triangle next. The triangle, you need to do the 1/3 rule. So you go 1/3. 1/3 of this is going to be 40, right? So 1/3 of 120, you see you get it 40, positive 40. And that's the x distance. Where is it? See it here. But for the y distance, it gone down here. What's the total distance? It is 60. 1/3 of 60 is 20, but it's minus 20 gone below. Right? Gone below 0 point. Remember here says 0 point. And then for the next one, semicircle, you apply the rule. You find the area, you know if you find area of semicircle already. Pi r squared divided by 2, you get the area for those sections, see that there. But the triangle, the circle is a negative area. You see that? Only the circle alone, as I told you, that is a negative area. That's a negative area. To find this one, to get this, the x bar for this, you have to use the 4 upon r 3 pi. You get that distance there. And then now, where is it? It says up here, some distance up there. You have to add that distance to the 80. So you have to add this distance to the 80. So the 80 there waiting for it. So the 80 there. And then for the x, you could call that x, that is what? 1, 2, 3. So this is x3 is your 60. See it there. No, it's a semicircle. See it here. So the other one would have been the 25 plus the 80. See that? The last one, which is a circle, it's at the center. So look, y is 80. Yeah. And for this one now, you have to what now? The radius is 40. 40 to what distance carry out there? 40 to the center of this was what? So it's 40 from that, so it's 60 going to carry out there. So remember, this is 40 plus 20 carry out there, so it must be 62. Right? So 20 carry out to this point here. So remember, 20 carry out there. So if you notice this circle, this distance across here, you know is 120. Midway is 60. So that is 60 carry out here. So each one of them, you map them back to the origin. Map them back to the origin for each one. And you simply, this is nice way how to do it. Says x times this one. So right, so the area, look. So the area of this times this value give you this. The area again times y value give you this value. Right? The x bar times this one give you this value. And y bar again times the same area give you this value here. And you do that with each one of them. If you notice that there's one of them, the triangle is minus. One of the triangle components is minus because it go below 0. So see it for the y bar, for the y, one of them is minus just because of that. But definitely you know the circle was both the area is minus, so both components are going to be minus. You add these together, make sure you observe the signs are important, whether plus or minus. You add them and you get that value. You had these, only one minus for the x, right? And you had this. When you finish down here, so it's just a matter of applying the rule. Same rule. X bar is equal to the sum of x bar a divided the root of a, the sum of a, and the same thing for y. So y bar is equal to the sum of y times the area, right? Upon sum of the area, right? And it's simple, you get it here, all right? Let's run along. So see here, you see that's all you do here. You get that value, and you get that value there, and the same thing here. So that's a good demonstration of it, quickly. All right, let's run along. Next one now, let's do the inertia. See if we can have some time quickly for our question of today, because we don't start it yet. All right. moment of inertia, we started last night, right? So you same composite figure, you need to understand this thing they call parallel axis. So the parallel axis is a principle by which you're mapping axis together. So if you're finding the inertia to the x-axis using through the centroidal axis, you're talking about these two lines that are parallel, x and the x prime axis. Those two lines are parallel, but you're going to use the y component between them. You realize that only the y component you're using between them. If you're finding it in respect to this, so it's in respect to which axis you are talking about. If it's the x-axis, you are focusing on these two, right? These two lines, that's what they call it, the parallel axis theorem. So some element inside here, so it's parallel to the line down here. So the beam will tend to want to rotate around this point, around this axis. All right, so it rotates about the centroidal axis in respect to the x. But it could do likewise, it could rotate around the centroidal axis in respect to the y. And if it is respect to the y, we're talking about these two axes. All right, talking about the y-axis, if it's respect to the y, and we're talking about this line here. And you use the y components, the x component, if that is so, to rotate it. So guys, we tend to rotate around this axis, but you're using this component like a radius. So you have to relate the points in respect to from the center of this to each segment of each figure. So that is why they call it the parallax theorem. The first part is use a standard formula because you would have break it out into standard figure. The second part is where you get the center line through that figure, mapping it back to the origin to get the second section. Some of them, if it pass through the axis of symmetry, it has none, right? And that part, sometimes some parts are zero. All right. So for this one, what we did last night, we said that this is a rectangle, this is a circle, one here is minus. You would first find the centroidal axis. This is given. This is really 75. You can see it's given there. You can right, so you determine the component, determine the segment, guys, is inertia. So you know that y bar here is 75. So this is given in this figure, right? So basically, look at it given. And you can see what is x. X is 50, right? So for both of them, we know that. The intent now is for you to find the inertia. Having those components, how do you find the inertia? So you find the inertia in respect to the parallel axis, right? So now apply the parallel axis theorem to each segment you have identified, but they never said towards a parallel. So this one, but they put x-axis here. So which axis are we talking about it? So you can rotate about the x-axis through the center. So that is the centroidal axis, and it's going to tend, body want to tend to rotate through that part, and that is the inertia. So you're using the y components. So you look for where the line is to the center of this. And in this case, it is easy. It is 75, right? So the inertia for this one, so all you would do here, for this figure, the inertia for this is 1, if it's a circle, 1 r times pi r to the fourth. That will be the first part. The second part will be here of this figure, right? Times the inertia distance between these and this line here. So that is 75. So that's your d, your dy, right? So your dy there is 75. What about this guy here? For this guy, the dy also is 75 in this case for both of them. All right. So that is simply what it is. Like this is a table. Come on, come on. This is a table that you would typically use. So what you do at the end of the day, you would come on again. Where are we? Where are we? So here now you have a table where all these values for a circle, for a rectangle, pardon me, this is the formula BD. Sometimes we use D instead of H, so I tend to say BD cube is the same as BH cube, which is mean the breadth times the height. So I call this depth or height, and this is the breadth. Right? Some of you might want to call it base, so whatever. And the same thing for the triangle here, half base times height, right? And then this one, but you remember it's perpendicular height always, not the slant height, right? And the x, for the x for a triangle, the inertia is this formula. For a circle, inertia in terms of your x is that, and in terms of y. So they are the same, but these are the formula. For the circle, it's just 1 upon 4 pi r to the fourth. All right, these are standard. All right. You will provide with a table with most of these. So to find the total inertia, you would have worked out the inertia for the first part, add them together, work out the inertia for the second part. This was although all, you have to minus it though. So you'll have to minus it. You wouldn't have these two. You would minus one from the other. So see the inertia of the rectangle minus the circle because that's an other inertia. So and that is the overall inertia for the two figures. All right. Then now we had looked at this one now. Let's look at this one quick. This one now is different. We're going to show you why. So you must determine the moment of inertia of the beam's cross-sectional area about X and Y centroidal axis. All right. What you find happening here is this can be separated into a number of regular rectangles, if you notice that. So you can decide how you want to separate it. I would look at it and separate it across here. I would get one rectangle up there already. I could get two by doing the same thing here. So and then three. If you notice that the area of one and three are identical, right? So you determine, so you wanted to get the X and Y coordinate for the centroidal axis. Let's look how it done. So first of all, if I'm going to separate it this way, I could say that I have three rectangles. So I have one there. I have another one here. Let's put it longer just to make sure. And then the other one here. And the dimension for these are the same. So this would be what now? The thickness of it is how much? Is 100. So therefore, the thickness, this is going to be 300 I by 100. And the same thing for that. And that is 300. But this is 300. And for this one, it would be what now? 500 for the length or the base. And then the
Oh,
breadth.
sir, 400.
500. And then this one would be
Yeah, sir, sure, 100 for one, and then the 100 for the next
where?
one.
Well, let me check that. Let me check that. Let me check that. No, it's 600. Sorry.
So the longer one is 600 now.
600, yeah.
Yeah,
600. 600. Going too far. So 600 is full length. Look, see this here?
yeah, we use 300. Yeah, yeah, all right.
Right here. All right? Yeah, so you, all right. All right? So that is that. You could actually look on it and say that there's an axis of symmetry passing through the center of the middle one. So the middle one, when you're doing the inertia for the middle one, it will not have a second part because it passes through the centroidal axis. Only these two will have two parts in the inertia. This part will only have for the area of the circle, which is BD cube upon 12. All right, so let's look at it quickly. What you do here, so you'd separate it into figures that you know. You notice one of the things you know is that they have done, they created a Y and an X axis. It's important. So you could put it anywhere. You know, you put it at the centroidal axis, you could put it at the centroidal axis, or you could put it out here. So you may use the question given the X and Y axis as shown above. But particular for a moment of inertia question, you may be asked to work with an axis about the centroidal axis. This is the axis that I'm talking about. So if it is about the centroidal axis, it makes the problem much different. Because right there, so the second inertia, for the second part, the part where it's talked about the area times d square, that is going to drop out if it is right here. All right? So what happens here there? So they have separated that into A, B, and D, right? So you must identify the composite figures, and you see them already. Now we identify them, be able to run along. So forget the inertia for the first part. See if I can see the notes here. What is the notes here? Really? It says apply the parallaxis theorem to the rectangle A. So let's look at rectangle A. Parallaxis theorem. So we're looking clinically at parallel to this one here. So with this one here, it was what? 300 by 100, right? So for the first one, it is BD cube. So this is 112 breadth times depth cube upon 12. So the what now? The breadth is 100. This one here, 100. See it right here. And the depth is 300. See it there. So it's 300 cube. First part finish. That is a standard equation, as I always tell you, the standard part. What about the second part now? You need to identify dy, which is the trickiest part. So dy now is always going to be the area times dy squared. So we know the area already. The area we had worked it out. So the area would have been, we had worked out the area, it would have been 300. Let me see, did we work out area? So it would be the 300 times 100. Everybody remember that? Because that would have been the area of it. It was 100 times 300 height. So here's the area. That is A, right? Now, what about D now? dy. How do they get dy? So dy, they are finding it in respect to the x-axis, right? But in terms of the x-axis, let's look. So it's the center of the figure down to where the x-axis is. So the x-axis is right here. Let's look at it good. All right? How did they get 200? So that is where the x-axis is. This will almost be the negative x-axis, so to speak. But anyway, that's where x-axis is. What they do now, you're going to have to look where the center of this figure lie. Halfway of this is what? Is 150 or so. You agree? Half of that is 150. Do you agree? Hello?
Yes, sir.
Yes, this is 150. After you're getting 150, what's the thickness of this? 100, not true? Agree?
Yes, sir.
So half of this distance here is 50, right here. So you agree?
Yep.
The distance, this little distance right here. That little distance. You see where I'm marking? You see where I'm
Yes, sir.
marking here? That is 50. So it is going to be 150 plus that 50. So that is, so it is always going to be a distance mapped to where your centroidal axis is. Your centroidal axis is right here. It's how you could have called that C. That's where your centroidal axis is. And it maps this distance right down to here, which is 200. So that's how you get the 200. So them have the 200 up there. So that's D. And you simply work it out and you apply it, and that's it. What about if they ask you for Y? You notice that the here, so now they're doing both of them together. And it's probably not a bad idea. So we're going to erase all of that. Now, suppose they ask you, that is to in terms of the X. What if you're asked to find the inertia in respect to the Y-axis? Look keenly now. How did we get all of this to the Y-axis? Yeah, how do we get all of this to the Y-axis? Why is this thing coming up? Trying to get my right about. No, wrong one. Right. I have my writer down here, but then, oh, see it here. So how did we get the one now? So if you're doing it in respect to the Y-axis now, which axis are we talking about? See it here? This Y-axis here. This Y-axis is what we're talking about. So we're not doing this one anymore. We're not busy about that one. We're busy about this one. So if you're doing it with respect to the x-axis, you're going to have to map a distance from here, so to that distance. Right. So look. Right. So, but look now. So this one now, it is going to be, so the first one is going to remain the same. The formula is going to remain the same 1 upon 12 BD cube. All right. Now, watch a trick. Watch a trick now. Your line of sight is going to be this way now. First time you were looking this way. Now you are looking, so you're not looking here so anymore, you're looking over here. So why is your breath now? See your breath here? That's your breadth. Where's your depth? It's your depth here. That is the rectangle you're looking at, but you're looking at it from a different angle now. Right? So your way of orientation of looking on that rectangle, this is your line of sight, and so you're looking on it. So this becomes your breadth, this becomes your depth. So you have to change your orientation, and this because it is inertia to the y-axis. So look now, let's look at it. The distance across here, so so this is your breadth. This becomes your breadth, and this is your depth. Your depth now will become what? 100. And your breadth is what? 300. Do you agree with that? So if you notice them rotate around. So what is your breadth and depth up here? Them change around. So this is now 300, and this is now, so that is breadth, this is depth. The depth now is 100. So see there? After you finish that, is a standard thing from the table. The next thing you're going to do is try to find your distance between your dy now. What your dy is always, your dy is a distance that is always mapping from the particular axis that you're rotating to your centroidal point. Right? Where am I? Come on, don't mess with me. Where am I? Right. So let's look for that axis now. So here now you're looking, and let's look on it again. So here we say that this is the distance you're looking for. So let's find that distance. What is this distance here? This distance from ear to ear. All right. The distance between ear was what? This is 100. The distance from ear to ear was 300. You agree with that? It was 300. So this distance is 200. This distance right here is 200. So if that distance is 200, what is this? What is half of this here? Half of 100. Remember, 100 is over here, so this is 100. So half of 100 is 50. So this distance right here, so is 50. So it's 50 plus the 200. So that total distance there is going to be 250. So 250 is that distance that you're interested in, from the centroidal point to that line there. So that is your 250 line. So that is your dy. So your dy again is times the area of the figure, which doesn't change, right? Whether you want to say 100 times that or 300 times, it's the same, right? And this is your dy. So in this case, for the y, that is the inertia in terms of the y-axis. This one is the inertia in terms of the x-axis. All right, let's run along. So here now, it says here, apply the parallaxes theorem to the rectangle B. So rectangle B, if you look here, this is rectangle B. Now look carefully now, carefully, concentrate. And we're going to find the inertia for both the y and the x component. Now, note carefully that the centroidal axis pass through the centroid in this case, because this is where x and y plane is. So this is y and x, so this is your 0 point, and the centroidal axis is the same place. You agree with that? Right? That is also known as the axis of symmetry. Right? So your central axis in this case is the same place where your 0 point is. So because of that, this is a rectangle that you're looking at, and its center is going to be 300 on either side. 300 on either side, right? So what they're saying here, for the second part, this part of your equations, they will drop out for both of them. Right? Because there's no dy. There's no distance between your 0 point line and your central axis. It is 0. So between where your origin line pass and your centroidal line, both of them are 0. Them lie on the same plane. So it is axis of symmetry for the middle piece. And so that second piece, and only first piece is relevant. So if you're looking on the first piece, for your breadth is here, and depth for the x-axis direction. So this will become 1/3 1/12 breadth times depth cube. If you are rotating it if you're looking for the y now, your depth is gonna become your breadth and vice versa. So it rotates around here because this now you look in this direction for the y. This now has become your breadth and this now becomes your depth. So it's shift around, right? So that now that is 600 is the depth and this is the breadth. So therefore you get two different answers for the same section. And likewise, the latter part is the same thing like how we did before. It has both sections. This section down here, section D, right? And typically to get the total inertia, you're gonna just add the inertia of this. All of the inertia is gonna add together. So you're just gonna sum all, but you're summing all of them for the x and summing all for the y. So you sum everything for the x, sum everything for the y, and that's it. And you get the total inertia. All right, now that I have done that, I'm gonna allow you to, oh, we have jump over this one. I don't know, oh, yesterday I reached this one. This is the one that I should have done in class. I'm gonna have to try and go back through it for the others. This one here, where is it? This one here, you already know what to do. Let's move to the question of the day. Right? So you will figure that one out. You have another one there. You can look through and do it. Let's go to the question of the day. Everybody remember the question of the day? You need to at least start the question of the day. Come, let's just jump to it. So everybody at the same page. We had given the question of the day yesterday. This was it. So I'm gonna open it right now. All right, you remember this question here? This is the question of the day. So you're gonna do two things for me. You're gonna find the mass, the area of the plate, the mass, and the centroid. Those three questions we're gonna solve today. So let's open them up and you're going to tell me what to do, or we're going to proceed to do it with your help. All right? So you are going to tell me exactly what to do. All right. So we're going to go to our favorite place. I hope it works well today. Last week it messed up a little bit and was not behaving. It crashed in the end, so I couldn't even save the file. I hope it behave a little bit better. Let me be as gentle as with it, because I haven't tested it really. Sometimes you know this all these softwares is start run already. All right. I'll be as gentle with it. All right. And maybe what I should have done was to cut it out, the figure itself. But I wanted to figure out the question. All right. I know what I'm going to do. So I'm going to make this big so we can work with it. And then I just crop the figure itself. So we don't have to, you can see it properly. All right. Is it too big now? All right. So you guys read the question now because I want you to help me and to tell me how you're going to solve it. So that's a figure. All right. And we have the question already. One part of the question there already. Let me see if I can paste it here. Might not allow me to paste it otherwise. So okay. Once the running bar is there, it's not going to allow me to paste it. So I try to be gentle with it. Be careful. All right, I don't want to start to give me a problem like last week. All right, here we are. So that's a figure. All right, nice and clean. All right. Now they want you to find the question say here to find determine the area of the sheet. So the first thing we're gonna do, determine the area of the sheet. So let's determine the area of the sheet. You're gonna tell me how many figures can this thing be separated into?
Sir, three.
Yes, sir.
Two
Three.
rectangle and a semicircle.
All right, so let's see it. So we see that we have a semicircle. All right, so we have semicircle here. All right. Let me just run the line straight across. So we have a semicircle. All right. All right. So let me get that out. All right. So we have a semicircle. All right. So we have semicircle. That is one. All right. And then we have our what? We have a What else you say we have now?
Hollow squared and a square circle.
So that's era one. And then you have a square, you say it is. What if it's a square? Where you going to check?
Rectangle.
Yes.
As a rectangle. Where you going to look at it? So we have two of them. So let's check them now. So, all right. What's the dimension for the semicircle? Body can see. What's the dimension?
Radius is 3 centimeter.
All right. So what's the diameter?
6, sure.
All right. So we have the diameter. Beautiful. What's the so the one that with what the small semicircle? Call that A2. So not semicircle. Rectangle. What is that dimension?
I
How much?
3 centimeter high.
3i. And what's the base?
with
Is 4.
the four square seems 6.
4. Good. And then the big one now. The big one is 6. We know that, so that this part is 6.
5 by
And the height
6.
is 5. So it's two rectangles. So we're going to call that one A3. So this is A1. For all our intents and our purpose, we call that. All right. So, okay. So let's find the area of A1. What's the area of A1 now? So it's pi r square upon 2, which is going to be pi, and the radius is 3 square upon 2. Please tell me the answer for that one. All right. I'm going to do the next one. So the area of A2 is length times width, so it's 3 times, what you want to call length and height or whatever. So that is 12, and this is 12 what? Centimeter square. You could choose to do the conversion before, but it's all right. We can keep it that way. I know why I said that, but it's all right.
14.34. 14.13.
37.
137. 37. 137.
Centimeters square. All right. The
Yes.
next one is the next area. That's area 3 is equals to what now? So it's 5 times 6. So that's 30 centimeters square. All right. So therefore, we want to calculate the total area. So the area total, which is total area symbol, says area 1. But which one of them is minus? This is a minus area, not true. And why the area is negative area?
So A2.
So it's A1 minus A2 plus A3. So A1 is going to be 14137 minus 12 plus 30. Give me the answer for that now, please.
32.137.
32.1.
1 cheese.
Let me write it down. 32.137.
37, sir.
And that's centimeters square. All right, cool. Nice. So that's the first part they asked us to do. They said determine the area of the sheet. Then the next thing, now that we find the area, we must find the mass of the sheet metal. How do you find the mass of the sheet metal now? So typically they say you have to find you get the density, but they want the mass. So they want the mass. You have density, and you know density is equals to mass upon volume. So we need the mass. Right? What is the volume of the sheet metal? If you get the thickness, you get a thickness here now.
We get a thickness of 1 millimeter. So
Yeah, so the thickness, convert the thickness to meter. How much is that to me in meter?
they're 1 times 10 to the negative 3 or 0.0001.
Right? Yeah. So right. So that is, I have enough zero there. Do I have enough zero there? I'm supposed to have 3 places at this one. 1 times 10 to the minus.
2 0, sir.
Yeah, it's a 2 0.
Yes, which is 1 times 10 to the minus 3. Right? Yeah. All right. The next part is, so that's the thickness. So therefore the volume, but we have to convert the area now to meters cube. So all right. So we know that 1 centimeter is equal to 100 meters. So what's the conversion there now? So how much centimeters? So
The
mean that,
other way around, sir.
yes. That's what I meant. Yeah. I'm going so fast. Yeah. I mean, so it's it's 100 centimeter because 1 meter. So therefore, how much equivalent of centimeter square to meter square? So 1 meter square is gonna be equals to this
Thousand.
centimeter all square. So that's 10,000.
Yes. Sir.
10,000 centimeters square is equal to 1 meter square. All right, so we know that. The next way, you're going to do a conversion here now. So you're going to convert the meters to the centimeters to meter, and it is what? 3217 to that. So in other words, this is going to be equals to 1 meters cubed times 32.2137 centimeters square divided by 10,000. And what is that answer, please? So that how much decimal point we have? 32 point, what is it? This is a 135, 135 I have there. Let me write it properly. This is 3,
Cheap. Cheap.
like 2. All
Sir,
right.
can you only
Pardon me? I got you. What is that?
0.00
So we get
3 2
3.2137
3 7
times 10 to the
negative 3
minus 3. And that is, the unit is meters square. All right. Square meters. So therefore, our mass is equals to your density times your volume. All right. So what is our volume then? Did we find the volume? So our volume, did we find volume?
Sir,
So our volume is your thickness times your air. So your thickness was 0.001, 1 times 10⁻³ times your area. The area, we just convert the area, so it is going to be 3.2137 times 10 to the minus 3. And what does that give you? Times 1 to the minus 3. So we're getting
3.2
3.2137 times 10 to the
negative
minus
6
6. And that is meters cube. So therefore, your mass is your density. What is your density volume again? See it up there. 7,800. And this is kilograms per meters cube times that volume there is 3.2137 times 10 to the 3. Oh, 10 to the minus 6, sorry. Right, meters cube. So the meters cancel the meters, and you're left with now kilogram alone. So that times 700. So it is 0.025 07. Right. So that is kg. Right. So if we want to separate the work industrial line here, so that everybody can see that. That is the calculation of the density. All right. So some persons tell me that they get 0.0251. They round it off. Right? All right. So that's your density. All right. Now let's proceed. All right. We have half an hour. We're going to do the centroid part now. You're going to tell me how we do the centroid part. I'm going to copy it, carry this figure down again. Let me just make a copy of it. Nice and easy. All right. So let's select him. Just want a copy of him. It's not even trouble. We're going to have a copy. We want a full page. Let's not start over here. I want to put it right here. Let's, huh? All right. Once I'm seeing the runner, I know it's going to get problem. All right. Cool. All right. So we have the era already. All right. So we have the eras already for them. Did we work them out? Yeah, man. We have the eras. So we can just copy them, carry down the eras. So we don't have to work that over again. Nice. We could actually put them right here so as not to cram our space. We want to just refer to it, put it close by. All right. Okay. So we have our eras there. All right. What I recommend you could do it two ways. You could draw up a table. So let's draw up a table. All right. I suggest we draw up a table. Let's see if we can get a table quickly. It's easier that way. So we're gonna draw some arrows. We want to draw some table. All right, so let's get a table going. Get enough space. All right. Or start for the using the red inches of time. We have, so we want at least five rows. We want some columns too. Right. So we have them wide. Figures might tend to be big. Okay. All right. So you can typically call the segments. All right. So you could start with saying how many columns we have. We have enough columns. So the eras, the segments, we have semicircle. Let's get a different color contrast. So you have segment. The segment, you could just put rectangle. The inches of time, you don't want to have too many unnecessary stuff there. So you just put, so this is era, right? Era that you're concentrating on. Our segment. Put segment first. It doesn't really matter seriously, but you just want to make sure that the table is very proper. So you could say the segment you concentrate on, and then the era of the segment. So you have semicircle probably first. Semicircle. Oh, why am I putting semi in there? Don't need to put semi after 30. So let's put circle. Trying to move quickly. Circle. Then you have that is era one. So this you have void was rectangle. Right? Then you have probably big rectangle. So as to distinguish them. But I guess the label could have distinguished them too. So one is A1, This is A2, this is A3. So there's no, so you can differentiate them. All right. So the area of this circle was 14.137. All right. 14.137. And this is centimeters square. You don't have to do any conversion, so I will only do conversion. Huh? Next one is minus 12. Make sure you put in minus 12. All right. And then the last one was what again? 30. So that is nice and good. All right. So you need to tell me what is x bar and y bar for each one. I will need to get XA and YA. Right? We miss out a total line. We can still put in our total line. We don't have a total line here. Alright? We want a total line. Especially that one and these two. Alright? So you want those, and this is your total line. Alright, cool. Alright, so this is your total line. Go back with the blue right. Huh? So this is your total line. Alright. Give me a total area, and then now we're going to identify x1 and y1. Alright, so for the first one, we need to find for the segment, right? For the semicircle, we need to find our x1 and y1. So halfway, we need to apply our formula to get that distance here, which is 4r upon 3 pi. Can somebody work that out for me? 4 times r. What is r now? 3 upon 3 pi. Did we work that out already? Not in this one. The one before. Work it out again for me, please. The one before, I remember it was 1.27. Is it the same? Incidentally, it might be the same. Check it out for me now, please. All right. How much is that? 12 divided
Yes,
by
sir, the same. 1.273.
1.273. All right. Nice. This is centimeter, though. That one was millimeter. All right. So that is that segment here. So it's some distance across here. So you need to map that little distance down to the bottom of the figure. What is that distance now to the bottom of the figure? That distance going down there. So it is 5.
5.
So it is, so your y, so this is your y bar distance is going to be, and I tend to call them y1 and y2, you know. I don't know why that's why I tend to call them. Kind of, so this is y1 for me. 1.273 plus 5. So that is 6.273. So, right? What is x? X1. So x1 now is going to
X
be,
is
see there?
the 3, yeah.
So that is 3 centimeter. And these are centimeters. So, all right. So let's put them in. So one is 6.273. This is, no, wrong one. I'm putting the x where, and the y where the x. Vice versa. So it is, this is 6.273, while this is 3. All right. All right. Let's do the void one now. All right. Use a different color. All right. So for the void one now, let me clean up this a little bit. For the void one now, how are we going to get this one now? So this one, half of this ant here is, so its height is 3, so it's 1.5 is the height up to here. All right. And for here now it was 4, so this is 2. But I agree with that. Those distances are 2.
Yes, sir.
Right. So we need to map it down from this distance down now to here. What is this distance coming down? We get our y2. So it's 1.5. What is
There's
the
two.
distance here? Anybody can tell me the distance from here down?
There's two. Wait, hold on.
Because
From
remember,
there,
this was what? 3.
1.5.
3, so this is 2.
Yeah.
Because remember, how we get 2 here is that this distance here is 3. This distance here is 3. So 3 from 5 must give you 2. Right? Because that dimension here so is 3. 3 from 5 is 2. So it is therefore going to be 2 plus 1.5. Agree? That is for the
Yes,
y.
sir.
So that's 1.5 for the y. So let's put that down there. Persons who will understand. So that is 1.5. This is 2. So okay, so the next one now. So this is how much you say this is 3.5. 3.5. All right. The other one now is 2 plus the distance here is 1. So this is says to get it out to here is going to be 1. And this come down 2. So that is 3. So we'll get that as 3. All right. Next one now, the biggest one, which is supposed to be probably the easiest. Let me clear them up again. So you can see them clearly. Yeah. All right. Come again now. We're gonna go with a different color. I'm gonna go with my green writer. So we have this big circle, this triangle here. All right, and this is the easiest one. All right, remember our origin is always there. So half of that is 2.5. So you can say that your y is what? 2.5. And your x is what? Half of this is 3 and that is 3. So your x is 3 and y is 2.5. Agree?
Yes, sir.
So we can draw it over here. And that one is our given one. Can only see it so you not have the green writer. So this is 6. Half of 6 is 3. And this is how much you said that was again? 6 too? Oh, this was 5. It was 5. So half here is 2.5. Let me put it properly. 2. No, this is 3 and this is 2.5. I just want to have a figure there that somebody can evaluate and they can look and understand it. All right, so that map it back to 0. So therefore, our x is 3 and our y is 2.5. All right, so from that now we can get a block writer and go in the column. Oh, by the way, which one? Anything in minus now? We have the minus here already, so that follows. So all right, we're gonna do them now. 14.13 times the first column. How much that gives you? So it is 14.135
42.411.
times 3. Is it gonna give you what?
42.411.
42.411. All right, and then the other one is 14.137 times 6.273. That gives you 88.68. Right, so that is that. All right, the next one is the minus here and now. So it's 12 times 3. That's what? 36 minus 36. And then the other one is going to be 3 times, no, not 3, 3.5 times minus 12. So minus 12 times 3.5. How much is that? How much is that?
And negative 42.
All right. Last one here now is 3 for x times the area is 90. and then the other one would be 2.5 times what? 30. So that gives you what? 75. All right. So what's the first? Yeah, the total area add up to again. We had found the total area before up here in our problem. We found it, right? It was what? 32 point
Yeah,
here?
32.137.
35. Yeah, 32.137. So this is, make sure it was right in the 32.137. Yeah, man, I think it was correct, in fact. So remember, you had minus the 12 from it. And then the other columns now, how the other columns? So it is 42.411 minus 36 plus 90. How much you get? How much you get? Hello?
96.411.
96.411. All right. What about the next one now? Remember to minus. So that one should be about
121.68.
121.68. All right. So from that now, you can find the centroid, which they wanted to find. Remember, they want the centroid of the body. So far we found three parts. The centroid of the body now. And if we can do the inertia, we do the inertia too. The centroid of the body. So we want the centroid X and Y component. Yeah, so let's do it quickly. Time is going. I have a presentation now, so I can't stay late today. All right, so the first one, it says X bar is equal to the sum of, so this one is really this workout going to be the sum, right? And that is workout to be the sum. So it's going to be the sum of X here upon your sum of your area. This one workout for X is 96.411 upon 32.137, right? And then the other one is Y bar is equals to sum of Y area upon sum of the area. So I want you to tell me the answer for those. And this is upon 32.137. Yeah,
X bar is 3
this is 3. Yeah,
and the Y bar is 3.786.
right. And this is centimeter. And this is centimeter. And I think the answer they have is 3.8. Something like that. Yeah, approximately. All right. So the inertia part is left. You need to attempt the inertia part. Anybody have an idea how they do the inertia part? If I could lead you on with just maybe the first part. All right, let me lead you on with one part. So the inertia part, you'll be applying. So what you probably can do is draw each component separately and do it like how they do it in the problem before. It's a nice way to do it. So you start up at 5, right? You call yours a 5, and you draw a circle. Oh, that circle really look like you draw a semicircle. Drawing skill is after this. Yeah, so carry my white. Right. So you'll work out this. You remember you'll work out that distance already, down to here. So you know your y distant already, and you know your x distant. So this was x1, and your y1. What were they again? You remember them? They were,
3 centimeter and
oh,
6.273.
we have them in the table, don't?
Yeah.
Yeah, we have them in the table. Come to think about it. They're all in the table. Oh, beautiful. So they are in the table. One is 3 and one is 6.273. So this one is 6.273 and this one is 3. So you're applying, you want to find let me see what they want the inertia of. Did they ask you for both axes? Let's look at the question. All right, I'm just leading on because I won't be able to stay uh, today. I won't be able to do. I'd love to go up to if you had the time to. So we do mass one next week. We did era. We found mass inertia. Found that, and I think they asked you for where's the next one? Determine more inertia of share the area to the x-axis, and I think they want it to the y-axis too. Did they ask you the y-axis too? So
Z-axis.
axis the z-axis. So they don't ask you x-axis. So yeah, next week we'll do that one. All right. So let me just help you along here. We're gonna finish this one next week though. We're gonna finish this one. So I'll just lead you on for the first part. So the x-axis, that means you're focusing on x and you're using y components. So the x-axis, the first thing we just got our centroidal point. So let's map it out. So the centroidal point that we got for the figure, that x was what? 3. No, when x was 3, right? When x was 3, y was 3 point, y was somewhere down here. So it's this. So x was 3, y is 3.8. Somewhere probably about here. Somewhere there. So it's actually in the center. So this is 3, while y is y coming down, the y distance coming down was 3.8 approximately. Alright, so that y distance is that. Alright, this is 3 plus here. Which is really a given. Alright, we just confirm. Alright, so they say you must find now for semicircle, you need to find your I for the figure plus your A times your dy squared. What's I for a semicircle? You have to go into your tables. Now, let me show you. You're gonna go into your table. Let's look into the table. What is in the table? Can you see it in this table here? I was hoping that you'll be able to see it. Let me bring him up. So in the table, for your semicircle, for semicircle and circle is the same. Semicircle is 1/8 pi r to the 4. Can you see it? They're both the same thing for x and y. So what this is really saying, it is 1/8 pi r to the 4 for both x and y. So it's 1/8 pi r to the 4. So you go in and you apply it. One more thing. So for this one, it is 1/8 pi r to the 4th. Right. So you're going to, and then your area of it. What was the area of the semicircle again? It was 14.134. So we know that 14.134 7. Right. Times dy. So what is dy though? dy is the thing. Let's find dy before we move further. So dy is going to be a distance. This is the centroidal axis here. So you get a center coming from here. The distance we know this is 6. The distance, this y1 is 6. This distance here is y1. Y1 is 6.273. So it's easy. So it's a
So it's
distance. So it is
6.273
going to
minus
be
the 38, the
minus
3.8.
3.7, right? Minus x bar. What is called x bar. That is it. And you do that for all the figures then. So it is as easy as that. So this is what? Y bar. So it is going to be 6.273 minus 3.8. Give me the answer for that. So you give dy. How much is that?
2.473.
2.473. Right. And therefore, your I x now is equals to 1 upon 8. Let me go back to a black writer. 1 upon 8 pi r square is 3 to the 4th. Plus the area was 14.137 times the d square, which is 2.473 r square. Right? Can work out that one. Let me attempt the next one quickly. So the next one is you have same figure, right? And this was your figure. And how it look again? You have the semicircle in the middle of it, or it's resting right on the semicircle. All right, let's remind myself. And then it comes here, comes there. So it's resting right there on the semicircle. All right? Now if I put in the other figure, I just want to know where it resting. Can put in one guideline up the top here. So this was 5. This was, what else was 3, and this was 4. Remember that? All right, the center coming through here, so that would be 2 and 2 across. So the center was coming up to here was what? 3.8, and the x was, come on x, this x distance here is also 3, and this is 3.8. Remember, this is y2. Y2, you remember that?
Yeah.
No, what? The
Hold on.
centroidal,
Is
what was the centroidal?
I would say
The distance.
3.5
Yeah, the centroidal was 3.8. And
or
then,
3.5
yeah,
or
and then
yeah.
let's go for the Y2. 3.5. Let me just go back for it. So this was, so the center of it, what it means is that I draw this thing wrong. Hold on. It's supposed to be higher up. My perspective view is out. I'll probably put it somewhere about up there. So that is your 3.5. So? No, it's a 3.8. So that means the center of it, right? The center of it would have been where the center of this is 3.5. Right? Center up to this center of the figure. Yeah, that distance there. While the distance over here was 3 again. Right? So that is the center of the figure. While this is C. This is center C. So center C of the body is 3. This is 3 and this is 3.8. So it means that for that rectangle, the I2, right? Or you could call it I1 too. This is I2 is going to be, 1 upon 12 BD cube, which is always the area, initial of the figure, is always equal to I2 plus A D2 squared. All right? Because D2, so the area of the figure, we had that was 4 times, what was it? 4 times something, 12? Right, so it was minus 12. Right. So just work with 12, but there's no says I'm negative area. Negative thing. So you work with positive 12 there, but the D now, the D is going to be, what is the D now? The D is going to be 3.8 minus the inertia. So the minus the centroidal distance, sorry. So it's Y, so it's going to be Y, this YC minus Y2. You got what I'm saying? Square. You follow? Hello? You follow?
Yes, sir.
So the breadth is 4, meaning that this distance here is 4. Come on, where is that? Right, I can't see it now, you know. Oh, so fine. That is 4. That is breadth and this is height. So that is, let me get back a right, I can't see it. So it's 4 times 3 cube. Right. So that is that plus the 12. All right. We use positive 12 still. What's the difference there? The difference is 0.3 square. So that is the next one. And you can work out the last one. I'll leave the last one to you guys to work out. This is what I have. Yeah, because I have a presentation now, and let me just see if I could show you how to do the last one, which is easy. The last one now would be the bigger figure, which is the easiest one. And this is a solid area. So it is I3. It's going to be the I3 of the figure plus area dy square 3. So this one is going to be BD cube upon 12 plus the area of the figure was what, 30 times we need to work out what is our D. Let's proceed. So this was 6 and this was 5. We got this figure across here. We got that in the center here. Your centroidal axis is 3.8, which is not the center, somewhere up here. All right, I think that one is wrong. So it is about here, somewhere about here. All right, so that is 3.8. And then this is, how much was that again? 3. So, all right, so we have everything we need. So it's just a matter of putting it in the formula. Your breadth is 6, your depth is 5, cube upon 12, plus 30 times what was your centroidal distance here was 2.5. 2.5 was the center of it. And your depth of that, and this was 3. So you know it. So it's going to be 3.8 minus 2.5. All right, so it's that little distance. Look, it is this distance you're looking for all the while. So that is your dy. That little distance between where the center of the figure is and the centroidal c-axis. So for all of them, that's exactly what you're looking for. You're looking on the distance. So your d here is this little distance here, between where the centroidal axis is and the center of the body is. And for the other one, it's the same thing. So it's this distance here between this distance. That would be your D. Can I put a different color there to show you? So your D's are these distance right here. So your D's are right there. Right. So and you just simply work that out. Know that this one, your inertia area is going to be minus purple one. Believe me, I can't find the writer. It's too faint. Oh, here's it. So whatever you get here, remember it's going to be a minus inertia. All right. So you add up all of these, what these work out to be. If you can't quickly work it out, then I have to run. Because I'm gonna have to go.
The first one was 118.267.
This one, total workout?
Yes, sir.
100 and
118.267.
two. Anybody else can confirm that? And this is meters. This is centimeters to the fourth. You hear? All of them are centimeters to the fourth. So this one is centimeter to the fourth. That part is centimeter to the fourth, and you add them. So right? What's the second one now? So this is for my label them. This is void rectangle. So this is void rectangle. This one here. Back to O. And that would have been your X, and this would have been your Y axis. What's the second one?
Next one work to 10.08.
Let me get that down. It says 10.08 centimeters to the fourth. So this is minus though. Let me fix that. Minus this, that. Minus inertia.
Yeah,
Why is
because
it
it's the
minus?
void.
Because it's hollow.
Yeah.
Alright, so it's void inertia. Let me check, see if I have the answer. Just confirm whether or not your calculations are on we're trying to see if I find the answers. They're somewhere along here. Let me see. So the void one is supposed to be, I'm looking if I'm right here. Am I correct? The void one is, what you said?
10.08.
10.08. Hold on. So the one is, you got what? The one before was what? The void one is 10. No, you can't get 10. In centimeter, check it out again, man. Hold on. I might be mistaken. Let me look again. You sure? Something wrong. Look good, look good, look good, look good. So the void, the semicircle, I'm gonna do the semicircuit. How much you say you get?
118.267. I check again.
For how much? Show which one?
A semicircle.
100. No man, that no, right here, so. No man, the inertia, you know. I'm just checking the paper to the answer. Let me just check out the answers. Um, this is for the X. So I have 1.5, 1.5 plus that is 3. 3, I have 3.5 for the ocean, I don't know 3.5, but for the void, let me just check this for the void. The void was hold on. 3.5. Let me just see if hold on. H2 was just 12 times hold on, let me see if we get that right. Let me see. Which one is it again? The circle. So it is, what was the distance that we're getting? So it was, we got 3 point, I didn't get 3.5. Hold on. The second year working out the inertia. It was 1.5. So let's check the distance that we have here. So for the void section, your y was 3.5. Right? 3.5 minus 3.8. 3.5. Yeah, because we got the answers correct because this is the void one. Y is 3.5. This is x, so it's 3.5. And the central distance for y was 3.8. Uh-huh. Mhm. All right, I don't think that one is fully I'm gonna have to check it over again. I don't have the time now, but check it over. I will check them over. I'm trying to see if I find the answer. Do I have the answer sheet here? Let me just check the answer. Where do I find that answer sheet? I'm gonna check the answer sheet quickly to see if what we compute just now is good. Let's see. But anyway, next week I'm gonna finish it up. Let's check the answer for that section. So far we would have done all of this. Right. Did they work it out? So they have it as this look like -9. Did you get something like that? Close to it? I don't know. Let me see. Was that what they did? Let's see. So they got -9 for that is just a set section. They didn't fully work it out yet. So they got that. Okay. Oh, they didn't really work it out. This is for the table, inertia and the table. So these are the dy's. So the dy's, let me see which dy are they working out here in the table. These are for the standard part, and then they work out. I don't have the time to look through this. The d's, these are their d's. But this is a different d. All right, I will have to review that part. I'll pick up from where we left off. For the first part, you should get -9. For the standard parts, these are the answers for the standard parts. I don't look to me like they had worked out the other parts. So one of them get D. Yes, 1 year, 2.5, 6.7. These are some distance they work out. I'm not so sure if they had worked out those D distance. I'm not seeing it. All right. So we'll confirm that part next week and wrap it up. All right. I don't think this
Right,
answer.
sir.
Yeah, I don't think this answer is fully. So we'll pick up from this slide here. I'll save it, and we're gonna move on from here. Right. These are supposed to be correct based on what we're doing. Right. We just need to check out the measurements here. The measurements coming down here was 6 something minus that, so you get 2.4. Right, and then you square that, work it out. How much you say you get here? -10. I see them
Yes,
have
sir.
yeah, -10. Yeah, that looks good. And then the other one, the first one was how much you say I got for it? Was this value correct?
Yes, that is what I got.
That's what you got. Okay. And then the last one, you didn't do the last one. How
No,
much
I
you got?
didn't get to.
That is like how much is that? Let's do the last one because they're gonna have to run. Our presentation. The guys, others actually start already. 10, 6. divided by 12. You get 62, so that is correct. I think I see that there. 62.5, and that is centimeters to the fourth here, plus whatever that is. 3.8 minus 2.5. So you're getting 13, and it must be squared. Make sure you square all of them, you know. Did you square them?
Yes, sir.
For the last section. Did you
I
square the
think I
last
did.
section? So this is 50.7. Right. And then now you'd have had this part here plus 62.5. So you get something like 113.2. I'm not, so that is which section again? This is a void section.
The
No,
big
this is
section.
the big section. I don't remember what they got for that. The big section, how much I got? 112. All right, I will run back through it to see if we left out anything next week. Right? All right, so that is basically it. All right, so this is working it down to the t. All right, so you square this, and let me just check this working here. So it is 3 square times 4, divided by 12. I got 9 there, so and I think I've seen them with some 9. So you have 9, and then the other part, which is going to be 12 times 0.3 square. So that was going to be, what was the first part again? What you did get? 9? 9, when you did the first part, how much you got?
This first part, the first bit there.
Yeah, 9 plus 9. So you get 10.0. Okay, I see it. All of that is negative. All right. So all of that. And then they ask you to, all right. Okay. All right. I'll pick up from here next week. All right. See how we're not finished. I'll pick up from here and see. All right, guys. So that is it for us today. All right. We pick up and finish up the inertia part. All right. See what is it that they calculated there to make sure that they have it correct on the sheet. So it's always good to work the things for yourself. All right, guys, that's it. So have a good one. You hear?
All right, sir, next week.
All right, great.